Welcome to an introduction to Zoom. Zoom is a graphical sampling profiler for Linux. Let's start by taking a profile on our local machine and using the default time profile. This configuration samples each CPU every millisecond. As an example, we're going to profile GIMP, the popular open source photo editor. We'd like to optimize the Oilify filter. To start profiling, you can use a global hotkey. By default, this is Control-Tab, or you can click the Start button in the Zoom GUI. We don't need to select process or recompile any code. We just let GIMP do its work, and click Stop to end the profile after a few seconds. With the time profile configuration, Zoom profiles the entire system. You can view all processes together, a single process, or just a single software thread. Profile results are presented in three different views: a top-down tree of executed functions, a reverse call tree sorted by execution time, or as a list of symbols with parent and child call trees on the right. This is also known as a butterfly view of the call tree because the currently selected symbol is the center point, and the caller and callee functions fan out from the selected symbol. Double-clicking on any symbol name opens a code browser for that symbol. Let's look at Oilify since it was the most sampled function. You can see both source and assembly code in the code browser view. The source and assembly views are linked, so a selection in one view will trigger a corresponding selection in the other view. The code is highlighted according to the number of samples that landed on each line. The brighter the line, the more time was spent there. An overview of the hotspots is shown next to each scroll bar. This allows you to quickly navigate to the important lines of code. Yellow highlighting indicates time spent on that particular line of code, and orange highlighting shows total time spent on that line plus child functions called from that line. In both the source and assembly views, there's a column with light bulb icons. You can click on these light bulbs to get specific coding and performance hints. In this case, Zoom tells us that we could improve the performance of the code by optimizing the floating point division. The integrated instruction help pane on the right provides assembly level information about the selected machine instruction. For more information and help, go to rotatewrite.com, where you can find a FAQ, quick start guide, release notes, and feedback forums. You can also contact the Zoom developers by sending email to support@rotatewrite.com. This has been an introduction to Zoom. Thanks for watching.